Hey everyone, it's Mr. Aarons. Today we're going to be working on our 4-3 homework. So I'm going to whip through 4 examples of that with you. I am recording from home today. This is the first time I've done this, so bear with me. Alright, so we're going to do 4 problems from these. We're going to do number 1, 2, 7, and 9. So if you're with me here, just follow along. And today we're talking about some patterns, some functions, things like that. So I'm going to put some key things right at the top of this here. My first one that I want to put is my y equals mx plus b, knowing that this and this are important. This is the y-intercept, where y is when x is 0. And this one is the common difference. It's also known as the slope, and you'll see some examples of that. So number 1, they say a worker's wage W in dollars is a function of the number H of hours worked. Graph the function shown by the table. Tell whether the function is linear or nonlinear. So here's the table here. Right now I'm going to switch this from H and W to X and Y. And I'm just going to make myself a quick little table here. I see 2 goes to 20, 4 goes to 40, 6 goes to 60. Oops, that should be 6, not a 60. 8 goes to 80, and 10 goes to 100. And we can see here that they're skipping by 2, so this is going to be a little bit unique because we have to find that common difference between every 1 and not every 2. So we're going to have to find them for a couple things like 1, 2, and 3, but you can already probably see the idea of what's going to happen here. So the first thing that I want to do is I always want to find that 0. So I'm going to find 0 up here, and knowing that looks like I can see this pattern, how it's happening, I can assume that 0 is going to be at 0, as it looks like they're just timesing each by 10. So what I can do right now is I can plug in a few more. If I were to work 1 hour, it would be 10. If I were to work 3 hours, it would be 30. 5 hours would be 50. And you kind of get the gist of that. Seeing that pattern, making sure you're going through every one, because right now they're skipping by 2s. So what we're going to do here is we're going to plug this into our graph. We're going to find that common difference. What that means is our difference between each of our spots right here. Again, this looks kind of funky because we're going up by 2s, but we can see it's plus 10 each time. So I'm thinking y equals 10x plus, and then where is y when x is 0? Well, when x is 0, we figured out y is 0, so it's going to be plus 0, which we don't actually have to write. So this would be an example of what our equation would look like here. Now all we have to do to graph this is we're just going to put these numbers on our points. I can see they're all positive. My x's are going to go up 2, 4, 6, 8, 10. And these ones are going to go up by 20s. When we're graphing these, oops, that should be an 80. It shouldn't be too hard to see what's going to happen here. All I'm going to do is plug these in just like here, just like they're an ordered pair. So knowing that these are x's, these are y's. Right down here I have hours. Over here I have wage. And I'm going to go 2 goes to 20, 4 goes to 40, 6 goes to 60, 8 goes to 80, 10 goes to 100. And we could also plot those spots in between. I could see that that 10 would be 10. I could put all of these in between and go straight up right there. And that'll work out perfectly for us. We can see that graph is moving in a straight line, which makes it linear. Another way to know that is that we had a common difference. It went up by 10 between each one. So we know that is going to be a linear function. So 2 ways of knowing that is if there is a common difference all the way through, and if your line is either moving at a diagonal, a straight line, it could go this way, it could go this way, or it could be horizontal. Those are all examples of linear functions. All right, we're rolling on to number 2. They tell us to graph the function shown by each table. Tell whether the function is linear or nonlinear. So I'm going to look at this right here, and I'm going to start off by just taking these. I'm going to write mine in so that they're on my own. 3, 8. And they're just asking us to graph each function and tell whether it's linear or nonlinear. They don't even want us to find the equation. So right now I'm seeing that these go up +2, +3, +5. So before I start, I can already guess that this is going to be nonlinear because there's no common difference here. Our common difference is off. So I can already know that this is probably not going to be linear. Well, I actually can know that it won't be, but I'm going to graph it, show you an example of that as well. So it's going to be like this right here. And our x's, we're going to have a 0, 1, 2, 3. Our y's, we're going to go from 0, we're going to have a -1, 2, 4, 6, 8, 10. All right, so right here we have 0. When our x is 0, our y is -1. When our x is 1, our y is 0. When our x is 2, our y is 3. And when our x is 3, our y is 8. Now, if I'm graphing these, I can see that this is not a straight line. This is curving upwards. If I was on a curving graph paper, it'd be even easier to see. But there's another example. We don't have that common difference. So this one would be non-linear. There's not a common difference, and they're going up at a curve. Remember, linear means line. These are non-linear because there's a curve to that. Moving on to number 7. Each set of ordered pairs represents a function. Write the rule that represents the function. So we're thinking about our y equals mx plus b. They already told us that it was a function. That means it's going to be linear here. Or most likely, I don't think so, actually, for sure. So I'm going to start by writing these in a table. I see them up there. I'm looking at number 7. I'm just going to put mine in a table. I know x is the first number, y is the second. So I got a 0, 1, 2, 3, 4. And on this side, I have 2, 1, 0, -1, -2. I'm just looking at these right here and plugging those into there. You can see them. I'm just moving downwards. What this allows me to do is find that common difference. Right here, I see -1, -1, -1, -1. There's our common difference, -1. Where does that go? That's our m. So I'm going to write y equals -1x plus the y-intercept, which is where is y when x is 0. When x is 0, y is at 2. And I could simplify this to y equals -x plus 2 because we know -1x is the same as -x. And a way we could check this is by plugging in these numbers. So if I plug in 1 right here for x, then I plug in 1 for y, I would have -1 plus 2 equals 1, and that checks out. I could check another one. Let's do 3 here. If I plug in -3 plus 2, it would equal -1, and it checks out as well. So you're taking these numbers, you're plugging them into this y equals mx plus b, knowing that the common difference, which is this right here, goes in for m, and the y-intercept, which is this right here, goes in for b. Rewatch that lesson if you're having some confusions with that. And finally, we're on to number 9, our last one here. Tell us, a student says that the function shown by the table below can be represented by the rule y equals x squared minus 1. Describe the correct error. All right, well, first I'm going to write this out as a table. 0, 1, 1, 2, 0, -1, 1, 1, 2, 3, 3, 5, 4, 7. All right, right now I'm looking for a common difference. I see +2, +2, +2, +2. They have a common difference. That's +2. I'm going to plug that in for my y equals mx plus b. And for my m, so I have y equals 2x. And at 0, we have -1. So we're going to do 2x minus 1. And we can see their mistake right here. Instead of 2x, they made it into x squared, which would not work. Because, for example, if we plugged in 3 right here, 3x squared would be 9 minus 1 equals 8. And it should be equaling 5. If we plug in 3 for r's, we'd get 6 minus 1, which equals 5, and checks out. So you can check those just like that. Take a look at the rest of these. You're going to do all the problems here today. There's not too many. I know you can do that all. Come to my office hours if you have any questions. Otherwise, good luck with this and have a great rest of your day.